In 2024 and 2025, the artificial intelligence industry relied on brute force. Developers built massive, sprawling server clusters under the assumption that feeding more data and more compute into monolithic systems would eventually solve their operational flaws. Those early architectures failed the enterprise test. When deployed in highly governed environments, they suffered from chronic data leakage and unpredictable hallucination rates. You cannot run a hospital or a financial institution on probability. By 2026, the industry underwent a forced correction. The market dismantled the old models and replaced them with a structural foundation built for predictability. This rebuilt stack rests on three distinct pillars: reasoning engines connected via the Model Context Protocol, 3D latent diffusion for media generation, and zero dwell time cybersecurity architectures. We have moved past the experimental phase. Artificial intelligence is now deployed and managed as a deterministic, highly governed enterprise utility. This architectural shift was a strict legal requirement driven by federal oversight in high-stakes sectors. When healthcare organizations began adopting AI for clinical diagnostics and ambient scribing, regulatory bodies like the FDA enforced software as a medical device guidelines. These rules mandate that cybersecurity and strict logic gating must be built into the system by design from day one. Simultaneously, major media conglomerates aggressively defended their intellectual property boundaries, making the default data scraping methods of early generative models legally unviable. The enterprise market made its demands clear. Raw intelligence is a liability. Corporations legally require controllable, auditable intelligence. This diagram shows the technical flaw of the 2024 models, their core operating mechanism of next token prediction. They attempted to guess the most statistically probable response, jumping immediately from a user's prompt to the final output. Because it relied on probability, the system could not verify its own work. It inevitably produced logical fallacies that rigid corporate environments could not tolerate. The 2026 replacement utilizes a logic-based architecture known as reasoning LLMs. Instead of guessing the final answer, a reasoning LLM breaks a complex prompt into distinct subtasks. It formulates intermediate steps, evaluates the potential outcomes, and corrects its own logical errors before taking any action. Transitioning from statistical probability to sequential logic is the absolute prerequisite for establishing trust in an enterprise system. A reasoning engine is useless if it cannot securely interact with a company's proprietary data silos. The industry standardized on the Model Context Protocol, or MCP, to solve this deployment bottleneck. MCP replaces brittle, custom-coded API integrations. It acts as a universal gateway, allowing autonomous agents to query databases and read file systems in real time. To satisfy strict data residency laws, MCP ensures these agents operate exclusively within localized infrastructure, keeping proprietary information on premises. This shift toward localized hybrid environments is widely classified as Cloud 3.0. Together, MCP and Cloud 3.0 resolved the severe latency issues and data sovereignty vulnerabilities that disqualified earlier cloud-tethered models. We can see this architectural correction most clearly in the digital media market. In early 2026, OpenAI officially announced the permanent sunsetting of Sora 2, its flagship video generation platform. Sora 2 failed on two fronts. First, its default ingestion of copyrighted intellectual property triggered intense, unsustainable legal friction with rights holders. This chart illustrates the second flaw: mathematical inefficiency. While video resolution scales linearly on the x-axis, the required compute costs for frame-by-frame interpolation explode exponentially on the y-axis. Generating a video frame by frame means the model constantly loses track of object permanence. It has to recalculate the physics of the scene for every single frame, requiring massive, expensive error correction. Because of this heavy operational overhead, OpenAI closed consumer access to Sora 2 in April and shuttered the final developer APIs in September of 2026.
The collapse of Sora 2 serves as a concrete proof point. Throwing raw compute scale at a structurally inefficient architecture is a losing strategy. To capture the enterprise market, Google introduced Veo 3.1, a framework specifically built to solve the temporal consistency problem. The underlying technology powering Veo 3.1 is called 3D latent diffusion. 3D latent diffusion abandons the concept of frame interpolation. Instead, it treats time as a third spatial dimension, conceptualizing the entire video as a single three-dimensional volume. By locking elements into a continuous structural geometry, the system guarantees accurate physics, weight, and momentum over extended sequences up to 140 seconds. The platform also integrates native 48 kHz audio synthesis and an invisible synth ID watermark directly into the generation pipeline. Veo 3.1 became the industry standard because it successfully aligned high-fidelity media generation with both physical reality and strict corporate transparency requirements. Beyond media generation, we have to look at the cybersecurity sector to understand the new operational velocity of these systems. Threat actors are now deploying a new class of offensive weapon, dynamic LLM-powered malware designed specifically to bypass static defenses. The LameHug malware framework illustrates this exact capability. Once LameHug infects a system, it autonomously queries public LLMs. It analyzes the specific local environment and immediately rewrites its own exploit code to match the target. Traditional signature-based security tools look for known code patterns. They are effectively blind to an attack that generates custom code on the fly. This renders the standard security operations center model obsolete. If your defense requires a human analyst to verify an alert and authorize a response, you possess a fatal bottleneck. When cyber attacks execute at the speed of machine logic, any defensive architecture relying on human reaction time has already failed. The mandatory defensive standard for 2026 is zero dwell time containment. This diagram illustrates a traditional SOC timeline. Organizations are replacing this model with security action engines, removing manual human review. These engines monitor networks continuously. The millisecond anomalous activity is detected, they autonomously execute containment, isolating compromised devices instantly. Executing these split-second actions requires zero latency, which is exactly why the localized on-premises architecture of Cloud 3.0 is critical. True enterprise security now requires leaders to surrender manual execution to governed autonomous agents. This level of trust in governed autonomy extends beyond the server room. It is actively managing high-stakes operations in the physical world. Software-defined vehicles now derive their primary market value from sensor processing and over-the-air updates, prioritizing software performance over traditional mechanical specifications. We see this clearly in the commercial expansion of Level 4 driverless services across major cities. These steering wheel-free platforms serve as the ultimate proof of concept for zero dwell time reliability. The safety records of these driverless fleets demonstrate how specialized action engines operate under a governed logic. This establishes the baseline reliability needed to trust governed autonomy with the split-second execution required in both high-speed transportation and enterprise-scale security. Looking at the complete 2026 technical stack, we see a unified system. Reasoning LLMs routing through the Model Context Protocol, executing locally in Cloud 3.0, driving specific tools like Veo, and guarded by zero dwell time security. This architecture positions the technical lead as an intent orchestrator. The manual tasks of writing code, managing individual security alerts, or interpolating data points have been superseded by autonomous agents. Your new mandate is to set rigid architectural boundaries. You define the strategic intent, deploy the autonomous agents to execute it, and strictly oversee system compliance. Artificial intelligence has matured into a deterministic infrastructure designed for high-level orchestration.